Hello, everybody. I'm going to start by posing a question to you all, especially the Jamrose community. Is there any danger in running an engine that is underperforming? Is there any problem in continuing to drive a vehicle when it is actually showing that it is not running normal? Something is not right. What is the effect of ignoring telltale signs that the engine gives you every morning when you start it? You're used to your car, you know exactly that, yep, everything is fine, I can drive and go. But there are times when drivers decide to drive their vehicles when they know that there is an issue. So today I'll take you through some of those problems that can surface. And I also want to take you through the safety breaches that decisions that we take as drivers or mechanics or owners of the vehicle can actually lead us into. So stay tuned while I take you through this journey. I hope you're going to enjoy this. So before I delve into my subject today, I just want to pose a question to you. The engine is running. Can you tell the problem? I want you to listen carefully. I want you to participate in this video. Can you tell the problem? You started this engine and it's running the way it's running. What is the issue? If you look, it's shaking. Okay, listen to the sound carefully. You must be able to pick something there. So you hear that? I think by now I've given you enough clue. So let me take you now step by step uh, through the consequences or the result of running an engine like this, so that you can see at the end of the video, you will be able to understand the dangers or the repercussions. So please stay with me once more. So when your engine is off cylinder, let's look at what that will cause. What is it going to do? So it means that the particular cylinder that is not contributing to the overall running of the performance of the engine, that particular cylinder is not burning fuel, but the injector is injecting fuel into the cylinder, and yet that fuel has got nowhere to go. So that fuel will find itself down in the exhaust pipe. That's where it's going to go. If you go to the tailpiece and check with a fuel gas analyzer, you will find that that fuel is actually coming through the tailpiece as hydrocarbons. And you know, with stringent emissions in Europe, this is not allowed at all. This will fail an MOT test. So now we want to explore what happens when that fuel ends up in the exhaust system. What is the impact of it? Does it damage anything? Where is it accumulated? Does it just come through the exhaust and go at the back and that's it in the atmosphere?
What are the consequences of having a misfire for a long time on an engine? Because it, besides just using too much fuel, it will also cause other problems as well. So I want you to be able to understand from now on that when you have a misfire, you need to get that vehicle checked before it causes more damage, because it could be just a spark plug, it could be a coil, it could be something minor that is causing that misfire. So here I want you to listen. This is the exhaust, right? You can hear it clearly. You can hear the misfire clearly. So I just wanted to take you to the scan tool and show you what the scan tool is saying. So I just want to take you through the scan tool. What I have done, if I can just give you a heads up, I checked the spark plugs. The gaps were too big on one of them, so I had to re-gap it 0.8. This is a Yaris. So after that, I the misfire stayed, so I swapped the coils, and apparently now we don't have a misfire cord, but we have a crankshaft sensor cord, which is what I'm going to show you here. There you go. We have a P0336 crankshaft position sensor, a second range performance. So it's a performance issue, okay? It's a performance issue. It's not an electrical issue. It is a performance issue. That is important to note. So I want to take you underneath this vehicle and show you something here that is dangerous and that can cost you a lot of money if you don't take care of this misfire quickly. This can be dangerous, or it can actually cost you a lot of money. Let me prove that to you. I have turned off the lights in the workshop so that I can clearly show you. This is a catalytic converter. Look what is happening because of the misfire. Anytime we could have a fire here. Anytime, if this engine is going to be running for a long time, we can have fire here. Thomas, can you go and turn off the lights, please? I turned off the lights to show you. The red that you see is a catalytic converter. Right, the lights are on now. Okay, look at that. This is the impact. This is the result of a misfire. Okay, so whenever you're running your engine, you're running your car, you are ignoring taking it to a mechanic, this is what you are doing. So I can tell you, in a short space of time, we will have a problem with our catalytic converter, because what is happening now, a lot of fuel that is not burning in the cylinder is coming into the exhaust and then it gets lodged into the catalytic converter. As it is being lodged into the catalytic converter, it starts to burn, and hence you see this overheating of the catalytic converter. Okay, this is not a turbocharger. I've seen this with turbochargers, okay? This is a petrol engine. This is a simple cat, right? So all the hydrocarbons are now accumulating in the catalytic converter, and now they are causing all this. So the precious metals that you find in the catalytic converter, like your palladium, as I'm talking to you, the engine just cut out. Okay? That engine just cut out. That's how severe this misfire is. But I wanted you to see this. I think this is a learning curve for many technicians and young technicians, senior technicians. A misfire has got a lot of repercussions. So the owner of this vehicle will soon have a problem with a code like a P0420, if I'm not wrong, catalytic inefficiency. Okay, I may just try and check the lambda sensors. Let me check the lambda sensors and I'll scope, maybe not scope, I'll just graph them for you. I just want to see their performance. Maybe I'm just talking when already this catalytic converter has got an issue. It might not show a code yet, but we may actually find a catalytic converter inefficiency code, P0420, but I'll go inside and show this to you. Right, so what we want to do now is to check the temperature of that catalytic. Tom, you're not pointing to the cat. Point here. Point, yeah, right there. See that? That was 300 and something degrees. It's actually coming down now. If I had shown you, the temperature when the engine was running, it would be worse. Okay, I'll run it again because I want to check the inefficiency, but that's where we are. This is not good at all. Right, so now what we are doing here, we are trying to use the manifold, the exhaust manifold temperature to diagnose the misfire. So this is our cylinder number 1. We've got 77.5 degrees for cylinder number 2. So we've got cylinder number 2, we've got 86, 87 for cylinder number 3. Cylinder number 3 has got 200 and 81. You see that it's getting higher and higher. Go to cylinder number 4. Cylinder number 4 has 265. So you can see that cylinder number 2 and cylinder number 4, cylinder number 3, they are high. And then cylinder number 1 and cylinder number 2 are very low. This is where we were picking the misfire on cylinder 1 and 2. We didn't find any misfire on cylinder 3 and 4. So the fact that the temperature is down on cylinder 1 and 2, it shows that those engines, those cylinders are not participating in as much. There's not much combustion in those cylinders to cause the heat to go up. So the fuel that is contributed by those two cylinders into the catalytic converter is the one that is causing the catalytic converter to be what it is. So we have diagnosed this thing for you in many ways. We have a scan tool, we have this temperature sensor to show you that there is a misfire indeed, and that's what is causing that catalytic converter. So now I'll go to the scan tool and try and show you the two graphs for the O2 sensor. Let's see what will do. Right, so I've graphed the two O2 sensors for you, and from what I can see, this on my right, let me say maybe it's the O2 sensor bank one, sensor 1, it's switching okay, that's fine, that's what it should do. O2 sensor bank 1, sensor 2, it is not too bad. It's not switching as much, so I'm happy to see that it's not bad yet. If the O2 sensor bank 1, sensor 2 was now behaving like the bank 1, sensor 1, then we would know that that catalytic converter is gone. But for now, this catalytic converter is still working. So for the last time, we're going to take you underneath the vehicle. We want to show you the temperature correctly with the engine running. Last time we showed you the temperature with the engine that was turned off. So we want to run the engine and then show you the temperatures once again, and then I'm going to end this video. But I want to believe that you're going to learn a lot from this, and you're going to treat misfires as dangerous, and also knowing that this is fuel that is going, and it's not good for the emissions. It is not good for your safety as a driver. Imagine you're driving on the motorway and this thing is red hot like that. You don't know what can happen. A little bit of fuel on that catalytic converter, the whole car is on fire. So please take precautions. If you think that there's a misfire on your engine, take it to a garage, get it checked as quickly as possible. Do you see that we are reading beyond what this thermometer can do? Okay, it just goes high, it doesn't know now what the temperature is. So we are running the engine here, that's what we can all get. And it's over 300 degrees, roughly going into 400. So it's just reading high. I hope you're going to enjoy this video. Please consider to subscribe to Download Electronic Solutions and our